example, and we are going to graph y is equal to 2x divided by x squared minus 4. I'm hoping that it is almost becoming important that you just jump straight to factoring. Factoring is just another way of saying the function, but it really helps you out to clearly define it. What we notice here is that we have a horizontal asymptote of y is equal to 0. And the reason for that is because our degree of our numerator, again, is degree less than the degree of the denominator. So that's why we have y is equal to 0. Our vertical asymptotes, now our vertical asymptotes for here, what we notice is that my non-permissible values are 2 and negative 2. And they come from these factors. Since these factors are not canceled out with factors in the numerator, we have vertical asymptotes at negative 2 and 2. So I've just graphed this out very quickly. These are my guidelines for my function. Now, trust me, I do have an arrow at the bottom of one of these, but I better make sure that it appears on the screen. There we are. There's an arrow at the bottom of my asymptotes. They're dotted lines used as a ruler with arrows at the end. So really, I have 3 different domains with this function. It's kind of getting crazy. We have this domain over here, and it's broken up by my vertical asymptote. We have this domain in here, and then it's broken up by this asymptote and this domain over here. So likely, what I would do is I would create a table of values for this. I have my guidelines that I've drawn, and now I'm just going to take shots at my graph and see where they stick. So if you want, press pause, and these are the y values that I've selected, the x values that I've selected. And very simply, for the first domain is negative 7, negative 3, negative 2.11, wherever that might be, negative 1.99, 0, 1.99, 2.01. Now, these get really close to the asymptotes, 3 and 7. These are the x values that I've chosen. Hopefully they've made sense. Press pause and just simply fill out the table of values for each of these domains. All right, so let's get started. It's really tough to say, right? So I know that if I plug in negative 7 here, the top is negative 14. The bottom looks like a crazy 45. Okay, that makes somewhat sense. It's an ugly number, but all I know, it's close to 0, but it's negative. Please take that away from it. You don't need to know negative 14 over 45. If x is equal to negative 3 and I plug it into here, what I'd get is the numerator is negative 6. The denominator is 5. So I get negative 6 over 5, which is approximately negative 1. Now, if I plug in negative 2.01, now this is basically x approaches 2, but from negative 2 from the negative side. And I'm going to do the sign test. So if I plug in negative 2.01, my denominator would be a negative. Now you could either look at it this form or your factored form. And if I plug in negative 2 here, negative 2.01, this factor is a negative. This factor, negative 2.01, is larger than 2. This factor is negative. So overall, we'd have a negative divided by a positive. Negative divided by a positive. Overall, this is going to be negative. So I have my x values for that first domain. So please take these down because I'm going to have to remove the paper when I start to graph it. Now, if I plug in these x values into this function, Again, I'm going to use the sine test. So what I notice is that the numerator, 2 times negative 1.99, all I know is going to be negative. Divided by negative 1.99 minus 2, this factor will be negative. Negative 1.99 plus 2, well, this factor is going to be positive. So overall, I have a negative divided by, well, overall my denominator is going to be a negative. A negative divided by negative is a positive. So now I'm going to take a look at 0. The reason why we don't do a sine test at 0 is because it's not extremely close to an asymptote. So when I plug in 0, what I get is my output is 0. 1.99 might be surprising because our top is going to be positive. This factor, when I plug in 1.99 subtract 2, will be negative. This factor is going to be a positive. Overall, I have a positive divided by a negative, and that's going to be a negative. Maybe I'll switch to pen. 2.11. You guessed it, I'm going to do the sine test because I'm very close to an asymptote. So overall, my numerator is positive. This factor here, 2.01 minus 2, will be a positive. My second factor over here, 2.01 plus 2, is also going to be a positive. So positive divided by a positive, no matter what they are, is going to yield a positive. Ooh, this is hard work. So if I plug in 3, that's 6/5. 7th is, I don't know, 14 over 20 or 45. And the numbers are symmetric. So I'm just going to jump over here and graph my points. So negative 7 had a y value of negative 14 over 45. So I know that that's very close to 0, but it's negative. So I'm just going to put a point right there. At negative 3, I had a y value at negative 6 over 5. So which is a little bit more than 1, but nobody's going to really look that hard. Hope not, anyways. Your math teacher might have something better to do. Now, negative 2.01. Negative 2.01 is on this side of the asymptote. And what I notice is that it's negative. So really, on the left side of this asymptote, my y value is going to go down to negative infinity. So this part of the function looks like that. I got my first portion. The next portion here, now this is a symbolic point, right? I'm using this y value now. When x is equal to negative 1.99, it's positive. So when x is 1.99, it's on this side of 2. It's on the positive side of negative 2, and I have a positive y value. So I can assume that that y value is going to go up really high because I always envision a vertical asymptote like a force field that just goes zoom or zoom up or down. And what I've just noted, it goes way up. My x of 0 is 0. My x of 1.99 was a negative. And be very careful, and it's really odd, and we don't have enough experience really, but it cannot be a straight line. You have to put a curve in that, and that is because of the asymptotic behavior. You cannot cross a vertical asymptote, and the reason for that is because it's one of your original non-permissible values. I swear, we're almost done. 2.01. So I'm going to go in my last domain. My last domain, 2.01. What I have is my y value is positive, so that means that it's going to go way up positive. When x is 3, my y value was 6 over 5. When x was 7, my y value was 14 over 45, which is approximately, well, it's positive, but it's close to 0. So now, there we have it. This is my rational function. I know, but wow, that looks beautiful. I encourage you to use technology, use Desmos if you get stuck. Feel free to ask questions throughout the day. I know this is a very difficult topic. Good luck.